Hassan Abbas saying, thank you. Happy New Year to New Iranian Year to all of you. This is the first of beginning of spring is New Year, Iranian New Year. So Hassan Abbas Saib, we can't wait. Students should come should come on time. So it's 6 minutes late from the beginning of the course. Okay. So we already actually waited for 6 minutes. So of course I recorded the meeting, the lecture, and you can watch the video afterwards if you want. So any question? If someone has a question, you can ask now. Okay. So page 165, constructing basic shapes in Opencv. One basic functionality offered by Opencv is drawing basic shapes. Opencv provides functions to draw lines, circles, rectangles, ellipses, and so on. When building a computer vision project, you usually want to modify the image by drawing some shapes. For example, if you develop a face detection algorithm, you should draw a rectangle highlighting the detected faces in the computer image. So, if you have a program that detects faces in the image, how do you show the detected faces? You can draw a rectangle. Additionally, if you develop a face recognition algorithm, you should draw a rectangle highlighting the detected faces and also write some text showing the identity of the detected faces. And finally, it is a common approach to write some debugging information. You could show, for example, the number of detected faces in order to see the performance of your face detection algorithm or the processing time. In this chapter, you are going to see how to draw basic and more advanced shapes using the Opencv library. The following topics will be covered: a theoretical introduction to drawing in Opencv, basic shapes, lines, rectangles, and circles, and other things, okay? So you need Python and Opencv. You need a Python specific IDE, which we use Spider. You need NumPy and Matplotlib packages. Git client, of course, we already downloaded the codes, so we don't need them last. So Opencv provides many functions to draw basic shapes. Common basic shapes include lines, rectangles, and circles. However, with Opencv we can draw more basic shapes. As mentioned briefly in the introduction, it is a common approach to draw basic shapes on the image in order to in order to do the following. Show some intermediate results of your algorithm. Show the final results of your algorithm. Show some debugging information. In the next screenshot, this screenshot, you can see an image modified to include some useful information in connection with the two algorithms mentioned in the introduction: face detection and face recognition. You see here, for example, we have this picture and we detected that there is a face here. So it is face detection. So we draw a rectangle here. Also, because it is a face recognition as well, you know, what is the difference between face detection and face recognition? Who can say? Say that what is the difference between face detection and face recognition? In face detection, we say that is there a face in the image or no? But in face recognition, we should say this face, who is this face? For example, here it is said it is Lena. So it is face recognition. But when we just say that there is a face here, it is face detection. When we say that this is the Lena, this is Lena, the face of Lena, then it is recognition. So in this way, you can process all the images in the directory, and afterward you can see where your algorithm has detected wrong faces or even missing faces. So when you do a face detection and a face recognition, then you may have false positives or false negatives. What is a false positive? A false positive is an error. So this is an error, okay? A false positive is an error. A false negative also is an error. A false positive is an error where the result indicates the presence of a condition, when in reality the condition is not satisfied. For example, a chair is classified as a face. So this is a false positive. A false negative is an error where the result indicates the absence of a condition, when in reality the condition should be satisfied. For example, a face is not detected. There is a face, but it is not detected, so it is a false negative. So in this chapter, we are going to see how to draw some basic shapes and text in different colors. To introduce this and to review some concepts from previous chapters, we are going to show you two basic functionalities that we will be using in most of the examples in this chapter. The first functionality is building a color dictionary. So we want to create a dictionary for colors. We name it color, which defines the main colors to be used. So, you know, in Python, when you want to create a dictionary, for example, we name it colors, then we say keyword bracket, open keyword bracket, So we have a key colon a value, comma, another key, another value. So this is a dictionary starting by a keyword bracket and end with a keyword bracket, open and close. Actually, a pair of keyword brackets. If we want to show in schematic, this is the keys, this is the values. Okay. So when we say colors blue, then the value will be this. I will explain this in the code as well. Let me that I run the code, the spider, anaconda, spider. So it should be pointed out that this dictionary is just for training and practicing purposes. For other purposes, there are other options that you can use. A common approach is to create a constant.py file to define the colors. Each color is defined by a constant, like this. So I'm waiting that the spider is running. So we create a file. We say blue equals this value, green this value, red this value, yellow this value, and so on. Then we put this in a file with name constant.py. So when we want to use these constants, we say import constant. Okay. Then we can say, for example, constant.red. Constant.red will be this value. So I'm waiting until spider is ready. You hear me? Please send one. Okay. Yes, this course is for both groups. Okay. So I opened the file constant.py. So we defined some constants here. Okay, then we can use these in our code. Okay. Constants are usually specified in capital letters. For example, blue, you see, capital letters. And with underscore between the words. For example, dark, underscore, gray. Additionally, as we are going to plot the figure using matplotlib, we have created a show with matplotlib function with 2 arguments. So let me that I open testing colors. So we created a function show with matplotlib. Okay. It takes 2 arguments. The first one is the image we want to show, and the second is the title of the figure to plot. Therefore, the first step of this function converts the BGR image to RGB because you have to show color images with matplotlib. The second and final step of this function is to show the images using matplotlib capabilities. To put these pieces together, the testing colors script has been coded. In this script, we draw some lines, each one in a color of the dictionary. The code to create the dictionary is shown here. So we have a dictionary here. Colors equals. So this is our dictionary. This is our dictionary. So also we have constants here, and we say import constant here. Okay. So when we import constant, for example, we say constant.red. Constant.red will be this value. Okay, let me I run this F5. You see red is printed here, and we draw some lines here. Okay, I explain to you this. So we create an image. Oh, sorry, I didn't show you the screen. So you see the screen now? If you see my screen now, please send 10. Okay? Okay. So I show you again. This is a script. We call it constant.py. We define some constants. We define blue equals. So in order of BGR, the first one is blue. So blue is 255, and then 00 for green and red. So green, this value, and so on. if we want to use this constants in our code, we should write import constant. Okay, when we write import constant, then we can say constant.ret. So it means the ret in constant script. So ret is 00255. When we run the program, you see, when we run the program, you see ret 00255. So what this function, this script does, so we have a function show with matplotlib. It takes two arguments. First, the image that should be shown, and then the title of the feature to plot. Because we want to use matplotlib, this function assumes that the image is in BGR order. Then with this command, we convert from BGR to RGB. So we save img in img RGB. Then we write plt.image_show img underscore RGB. You see, import matplotlib.pyplot as plt. We write plt image show, then we write plt title, we send this title, and then plt show. So here we create a canvas to draw the image. We create a 500 by 500, 3 channels, uint8 picture. We create this. So all pixels will be 0. Then we write image colors light gray. So light gray is this. So all pixels, we take the value, this value, blue, green, and red of each pixel will be 220 with this command. That is why when we run this, you see the color of the background. If I change it, for example, if I don't use this, then all will be 0. I run it, you see, all pixels are 0. We draw some lines. I explain you how we did it. So if I use this command, run it again, you see, for example, each pixel, for example, I put my mouse here. Look here, when I go on the image, it shows X and Y and the value of each pixel. For example, here, you see, X equals 316, Y 61, here, I mean. And you see the values are 220 for 3 colors. So here we have a for loop. We say for key in colors. So colors is this dictionary. For key in colors, so we draw a line using the function cv2line. So in Opencv there is a function with name line. So we write cv2.line. This is the image that we want to draw inside it. This is the image, okay? Then we say from which point X is 0, it is coulombs. And this is the Y. Separation is a variable, its value is 40. So from 0, 40 to 540. So a line is drawn with this color. So key will be, for example, blue. When we say colors blue, then the value will be this. Okay, the value will be this. For the next, the value will be this. Of course, there is no. Sometimes there is no order in a dictionary. So the last one is thickness. The thickness of the line. So a line is drawn, then we add separation 40, then the separation will be 80. So another line from 080 to 580 with another color, because key also is changed. And in the end, we call show with matplotlib the image. So if you, for each color, we draw a line. I run it again, F5. You see, here the blue line starts from 0, starts from 040 here until 540. The second line 80. The second line 120. 160, and so on. You see different colors. The last one is light gray, a line here, but because the background is also light gray, we don't see the line. Okay, so if here it explains here to code to create the dictionary, we should use this command. I explained to you. This is the colors. There is a special color here. There is a special color here. This color is called rand. The key is rand, and the value is this. Okay, this function numpy random rand it 0 high equals 256. It is for creating a random color. Okay, if I run this, wait a second. If I create a new one, continue. So I write import numpy as np. Then I say x equal or p equals this. Then I say print p. Okay, then I run it. You see, it produces 3 values in between 0 and 256. Okay, this is what numpy random.rand int does. If I run it again, F5, you see 3 other numbers. If I run it again, 3 more numbers. For example, I can write 4. Okay, it doesn't matter. I think you understand. So this function works like this. So rand it we have low here is 0, high is 256. So return random integers from low inclusive to high exclusive. So this returns a random integer between 0 and 255, because 256 is not included, it is exclusive. So it return random integers from the discrete uniform distribution of the specific D type in the half open interval low, high. If high is none, then results are from 0 until low. So in summary, here if we say draw a line with a random, then it produces a random color. 3 integers between 0 and 255 for blue, green, and red. Okay? So if you want, you can see that some very different colors are included in this dictionary: blue, green, red, yellow, magenta, cyan, white, black, gray. A random one: gray, dark gray, and light gray. If you want to use a specific color, for example magenta, you should perform the following. You write this. What we do here. What we do here, for example, we say colors this, or we say colors key. Note that key is changed. If I write green, key equals key, for example. Okay, and separation equals separation. So if I run it again, you see key is blue, separation 40, key green, separation 80, red, yellow, magenta, cyan, white, black, and so on. Okay, and each time separation is incremented by 40. So let me remove this one. I just wanted to show you. Okay. Alternatively, you can use this 255, 255, actually a tuple to get the magenta color, but it is easier to use this dictionary rather than write triplets of numbers, because you do not need to memorize the addition properties of the RGB color space. You don't need to know that for creating magenta you should put 255 here and 250 adding blue and red gives magenta, so you don't need to remember it. You just can have this dictionary and copy it. When you want to use it, you say colors, for example, light gray or magenta or any other color. So also remember that you can use constant.py to perform this functionality. So in order to see how to use these two functionalities, which we use in most of the examples in this chapter, the colors function and show with matplotlib function, we have created the distinct colors script. If you execute it, you will see the next screenshot that I showed you this already. In this example, we have created an image of size 500 by 500 with the 3 channels because we want a color image, and a uint8 type, 8-bit unsigned integer. We have created it with a black background. Then each pixel is 0. It means that in the beginning, each pixel is black. In this case, we want to set the background to light gray, not black. If you want to change the background, you can perform the following. So you do this. Next, we add the functionality of drawing some lines, such one in a color of the dictionary, each one in a color of dictionary. It should be noted that in the next section, we are going to see how to create some basic shapes. So do not worry if you don't understand the code to create the lines. And finally, we draw the image using the created showWidthMatPlotlib function. The 2 arguments of showWidthMatPlotlib are the image to plot and the title to show. So now we are ready to start creating some basic shapes with Opencv and Python. In this section, we are going to see how to draw shapes using Opencv capabilities. Firstly, we will look at how to draw the basic shapes, and then we will focus on more advanced shapes. So in the next example, we are going to see how to draw basic shapes in Opencv. These basic shapes include lines, rectangles, circles. The first step is to create an image where the shapes will be drawn. To this end, a 400 by 400 image with the 3 channels and a uint8 type will be created. You see here, we create the image that we want to draw inside. We set the background to light gray by this. So this is the image or canvas in the beginning. Now we are ready to draw the basic shapes. It should be noted that most drawing functions that Opencv provides have common parameters. For example, for the sake of simplicity, these parameters are briefly introduced here. So most drawing functions in Opencv provides these common parameters. IMG, it is the image where the shape will be drawn. Color, it is the color, a BGR triplet used to draw the shape. Thickness, if this value is positive, it is thickness of the shape outline. Otherwise, a filled shape will be drawn. Then we have line type. It is the type of the shape boundary. Opencv provides 3 types of line. Line 4, this means 4 connected lines. Line 8, this means 8 connected lines. And line AA, this means an anti-alias line. Also, we have shift. This indicates the number of fractional bits in connection with the coordinates of some points defining the shape. We don't use shift at the moment. So, line AA option for line type produces a much better quality drawing, but it is slower to draw. So 8 connected and 4 connected lines, which are non-anti-alias lines, are drawn with the Bressenham algorithm. We don't explain it here, but you should know it. If you want to know more about it, you can Google it. For the anti-alias line type, the Gaussian filtering algorithm is used. Additionally, the shift parameter is necessary because many drawing functions can deal with sub-pixel accuracy. So for simplicity, in our examples, we are going to work with integer coordinates. Therefore, this value will be set to 0. So always we put shift to 0 in this course. We don't use any other value. Of course, the book has something more, an example how to use shift, but I don't say this, I don't teach it. So I explained line. The signature of line is this. The image that we want to draw inside a line. PT1 and PT2 are 2 points that we want to draw a line between them. The color of the line, the thickness, which its default is 1, line type. Line type can be 8, but it's better that we use line 4, line 8, or line A8, okay? It's better, we know that these values are integers, but it's better we don't use integer, we use the symbol. So the shift also is 0. So this function draws a line on the IMG image connecting PT1 and PT2. There are some examples here. A line between 0, 0 and 400, 400 with color green and with thickness 3. And other examples. I think it's very easy. Then we call show with matplotlib. And we see this. So a line from 0, 0 to 400, 400 in green. And other lines, okay? It's easy. But rectangles. The signature for the rectangle function is as follows. The image that we want to draw inside. PT1 and PT2 are 2 opposite corners of the rectangle. For example, we say there are a rectangle that its opposite corners are 10, 50 and 60, 300 with color green. And the thickness of the outline should be 3. If we put thickness minus, a minus value, then the rectangle will be filled. Okay? So we see the results of that here. Remember that negative values, for example, -1 for the thickness parameter, mean that a filled shape will be drawn. Okay? So for circle, the circle for the cv2.circle function is as follows. This is the image. This is the center of the circle. This is the radius and other parameters are like before. This function draws a circle with the radius center in the center position. So we see some circles. A circle with center 50-50, radius 20, and the outline thickness should be 3. This circle will be filled with blue. So here is the screenshot, is the output. The full code of the examples of this section can be seen in basic drawings. So I open basic drawings. So you see the code. I press F5 to run it. There is something here. Maybe it's better after show with matplotlib. I write cv2 dot wait key. So here F5. Oh, it doesn't go. For example, I say, oh, it's not good, I think. I can import sys, then for example after here I write sys dot exit. So I run it. So you see the lines. Okay, we create the image, we set the colors to light gray, we show the color, we show the image. Let me I also add it here. So with this command the program stops. So if I, you see, finished, I make it a comment. Now we draw the lines, some lines with these properties. Then we show it again, and then here we exit. So here the line. So I make it a comment. Now we again set all the, actually clean the canvas to draw again. We set each pixel again to light gray. It means that we clean the image. Then we draw the rectangles. Then we say show it. I put again here sys exit. I make this one a comment. So now we see a picture with rectangles. You see, these are the rectangles. There is a question. Oh, I repeat them. Okay, I try to explain more slowly. But if you have a question, you can ask. So what I added here is that I imported sys, that I can use sys.exit, because I want to see the results of each part of the code. So I add a sys.exit to exit from that location, to stop execution, to stop the execution and to show the results. So something else. So I run it. So I put a sys exit here. I run it again. You see the rectangles. So I make it a comment. Now we clean the canvas again. We put each pixel to light gray. There are some circles. F5. So you see the circles. Okay, -1 I explain here. For example, here we say draw a circle in image with center 50-50. So it is here, okay? Roughly, approximately it's here. Then the radius is 20, the color is green, and 3 is the thickness of this line, the outline. For example, if I will come back and change it. But the second one, a circle with centers 100-100, it's here. With radius 30, color blue, and -1 means that fill this, okay? A filled circle will be drawn. If I change it, for example, I put my 1, let me close this. So you see, now it's not filled. Okay, so if I put -1 again, you see it will be filled. I explain actually. I say it again. Remember that negative values, for example, -1 for the thickness parameter, mean that a filled shape will be drawn. Okay. So I think that today lecture was very easy. What do you think? Are you agree? Are you agree that today lecture, the materials that we taught today was very easy, very easy? What do you think? So the next section. So how much time we have? About 30 minutes. So, and understanding advanced shapes. In this section, we are going to see how to draw clip lines, arrowed lines, ellipses, and polylines. These shapes are not as straightforward to draw as the shapes we saw in the previous section, but they are simple to understand. The first step is to create an image where the shapes will be drawn. For this, a 300 by 300 image with the 3 channels to properly display a BGR image. This is why we use a 3 colors, a 3 channel, and a Uint8 type. So this is the image. This is the statement to create an image. We set the background to light gray. At this point, we can start drawing the new shapes. So, clip line. The signature for the clip line function is as follows. So, clip line, this function returns the segment inside the rectangle. So we have a rectangle, we have a line, the rectangle is defined by this parameter. It says, and we have a line PT1 and PT2, a line connecting these 2 points. So we have a line defined by PT1 and PT2. We have a rectangle. So this function returns the segment of the line defined by PT1 and PT2 inside the rectangle. The function clips the segment against the defined rectangle. In this sense, retval, so it has 3 return values. If 2 original PT1 and PT2 points are both outside the rectangle, then the retval is false. Otherwise, this function returns true. Otherwise means some of the 2 PT1 or PT2 points are inside the rectangle. So to understand this, look at this code. We draw a line in the image from 0, 0 to 300, 300 with green. Let me explain it. From here. So we draw a line from 0, 0 to 300, 300 in green. Okay? In green. Now we draw a rectangle from the corners of the rectangle are 0, 0 and 100, 100 with color blue. So we have this rectangle. Now we want to know which part of this line are in this rectangle. So you see this part from here to here. So we should call clip line. We send the rectangle to call the rectangle. We send the line, and it says that which part of the line are inside the rectangle. So we call it. So you see, this is the rectangle that we draw. This is the rectangle. The rectangle is defined with 2 ways. One way is that we have 2 corners. Let me show you. Wait a second. That I show you from the documentation. So you see, we have a function rectangle. We send 2 corners or vertex of the rectangle, opposite to PT1. Or we put just rect. What is this rect? You see here? This is an overloaded member function provided for convenience. It differs from the above function only in what arguments it accepts. Use rect parameter as alternative specification of the drawn rectangle. So how we define a rect? A rect actually is a tuple or a variable with 4 points. Okay? You see here, we have a tuple which has 4 values. These are the coordinates of one vertex, and these are the width and height. So the rectangle, I explained it in assignments as well. A rectangle is specified with two ways. One way is providing two opposite vertices. One way is to actually they are 2 points. You see, we have a pair of parentheses here, we have a pair of parentheses here, but here we have just one pair of parentheses, and it contains 4 values. 2 values are the coordinates of one vertex, and 2 others are the width and height of the rectangle. So anyway, so clip line accepts a rectangle in this way. So it checks that which part of a line from 0, 0 to 300, 300 which part of the line from 0, 0 to 300 will be inside this rectangle. If a part of the line is in this rectangle, then the red will be true, and P1 and P2 specifies a segment of the line, of this line that is in this rectangle. If red is not true or it is false, it means that the line between 0, 0 and 300, 300 is absolutely outside the rectangle. So when red is true, we draw a line with yellow. You see, with yellow from P1 to P2. You see, P1 to P2. So it is what we see here. Okay. Okay, I try to explain it again, but wait a second that I explain from the facing the lines too. Okay, yeah, let me open this. So I import this again. Now I write this exit here. I don't want to explain other parts now. So I run it. So we draw a line between 0, 0 and 300, 300 with green. Okay. It means this line from 0, 0 to 300, 300. Of course, the index of the loss is 299, but it doesn't matter. So we have a line here, okay? We have a rectangle from 0, 0 to 100, 100. It means this rectangle. Now we call clip line. We specify this rectangle, the blue one, and we specify the line, this line. And then we say, we call this, when we call this, it returns red P1 and P2. I don't draw the yellow line. I run it again. You see, we have a green line, we have a blue rectangle. Now we have clip line. When we call clip line, we specify the rectangle, and we specify a line. Now let me that I print red. You see it's true. And I print P1 and P2. You see it is 0, 0. Print P2. It's 99, 99. So the part of the line that is inside the rectangle will be from 0, 0 to 909, 909. So if I change the rectangle, so if I say look in this rectangle, the rectangle from 0, 0 to 200, 200, which part of line from 0, 0 to 300, 300 will be inside this rectangle? So I run it again. So I print red P1, P2. So you see from 0, 0 to 199 to 199. But when we want to, we don't need to draw this, the line and the rectangle. We draw this just to clarification. Okay, so if I print it again, it doesn't matter. So then we draw a line here. We say if red is true, then draw a line here. So we don't need to draw line and rectangle. We say clip line to consider a rectangle, this rectangle, to consider a line from here to here, and then check that the line from here to here is inside this rectangle. A part of this line is whether is in this rectangle. If it is so, then the red will be true, and P1 and P2 show the segment of the line that will be inside the rectangle. If the red is false, it means that no part of this line from 0, 0 to 300, 300 is inside this rectangle. Okay, so I run it again. Oh, yeah, you see here now until here it is yellow, but if I change it again to original code, then we will have this. Did you understand anything? If you understand something, send 1. If you understand fully, send 2. If you understand nothing, send 3. Good. Good. If yes, this function is a little difficult to understand, but you should know that clip line doesn't draw a line. This function doesn't draw a line. It just specifies whether part of the line that is specified by these 2 points is inside this rectangle or no. If it is so, the red will be true, and the part of the line, the segment of the line that is inside the rectangle will be specified by P1 and P2, a line between P1 and P2. But if no part of the line from here to here is inside the rectangle, then the red will be false. So this line, this rectangle, and this line that we draw, it is just for clarification, to illustration. So let me also write clip line here again. So clip line clips the line against the image rectangle. The function calculates a part of the line segment that is entirely within the specific rectangle. It returns false if the line segment is completely outside the rectangle. Otherwise, it returns true. So, let me come back here. So this is clip line. I just explained arrows. Okay, arrows I will explain in the next session. So today until page 185. So any question? If you have any question, you can ask. So in 2 weeks, we will have an exam. Yes, yes, assignments maybe are more difficult. I think if you understand the course, the lectures completely, and note on explanations on the assignments, then it is easy. Explain 3.1.1. What do you mean? Tarwil, Safa Abdul Jalil. So in 2 weeks we will have an exam until page 165. So okay, we will have an online exam until page 165. Okay, so if I want to specify a date, let me pick a date for the exam. The exam so 17th of April. Okay, 17 April 17. Okay, we will have an online exam until page 165 on April 17. Oh, it's Ramadan. Yeah, it's Ramadan. So is it a problem for you if it is in Ramadan? So maybe we do it before Ramadan. Propose a date, please. Propose a date. I think it's better we do it before Ramadan. So Ramadan starts here. Oh, we don't. Maybe we put it for 12 next week. Next week Monday. 12 of April. April 12. Is it good? It is before Ramadan. So here, yes. It's good. 12 of April. Before this until here, okay? So actually here, until page 163 or 64. So in April 12, at the exam contains several programming questions. Okay, so April 12, next week Monday. For the time of the lecture, you should ask Dr. Rahmani if you want to change that. Yes, the exam will be same as the programs in the course, in the lectures, and in assignments. Okay? Yes, we take several, maybe 2 or 3 exams in total. So the grade is divided between 2 or 3 exams. Okay? Yes, it is online. You should come on the LMS. It is on LMS. Okay? It is on LMS. Wait a second, I say you. So let's see, I explain to you. Okay, I explain on Monday. I say you the link. Actually, the link you should enter LMS for exam. The exam will be on LMS. Okay, so any more question? I write the information in the exam. Okay, you see that. If we have, for example, two questions, just two questions, then it will be 30 minutes. If it is three questions, that then it will be 45 minutes. So next week, Monday, we will have an exam, online exam on LMS, April 12 at 16:30 Tehran time until page 164. The exam contains several programming questions, 2 or 3. So I want to stop the session. Okay. So, في أمان الله. Goodbye.